What first started out as a minor problem has now proliferated to a global pandemic, including every single country in the world. Over the course of the last year, our entire world has been flipped upside down. But we are witnesses of some of the greatest medical breakthroughs in history, and this combination of technology and medicine has fostered the beauty of innovation.
Seeing the fusion between medicine and technology, I knew that whatever project I chose, it would encompass these fields. Hi, my name is Aman Chaudhary, and I'm a student at the Medical Science Academy at Hightower High School. As my project title specifies, I'm dealing with analyzing lymphoma scans using machine learning. Ever since I was a little kid, I've always had a passion for medicine, specifically cancer. The idea that our own cells can be a threat to us was very scary for me. Today, when we look around, in friends and family, far too many people are affected by this dreaded disease. And over the course of the last year, I was able to take my passion for medicine and my concern for cancer and merge them together into this project. I worked with two other people for this project, Mayank and Mihir Sekar, but for the sake of this presentation, I'll be focusing on my perspective. I decided to specify our project on a type of cancer known as lymphoma. Lymphoma is a cancer of the lymph nodes and the lymphatic system. The main reason for choosing this cancer was because it's one of the most commonly missed cancers, which is truly devastating considering that with proper treatment and a correct diagnosis, the survival rate is 80%. So I started brainstorming on how to improve the diagnosis process. As a high school student, my medical knowledge is limited. Therefore, I interviewed several lymphoma specialists to get a better understanding of the barriers surrounding detection of lymphoma. What we found is ultimately, it's dependent on a human eye to analyze these different scans in a timely manner. While wondering how to solve the issue of human error, I remembered machine learning. What is machine learning? Machine learning is essentially a tool that replicates human intelligence by getting smarter over time and with more information. If we look around the world today, we see machine learning is everywhere, from determining our For You page on TikTok, to recommending products on Amazon, to self-driving cars, and even predicting the weather. Machine learning is everywhere, and I wondered whether it could be adapted and help us in this project. I hypothesized that a machine-based approach using artificial intelligence could pick up on those findings that might otherwise go missed, thereby giving the radiologist more time to focus in on the little details. This served as my goal, to incorporate machine learning into the process of diagnosing lymphoma. I aimed to create a relationship between the radiologist and the software, in which the software would bring its reliability and speed, and the radiologist would bring his domain skills. With a clear goal in mind, we then created a plan for how to accomplish our project. In order to succeed, I need to A. Collect training data, B. Create the program, and C. Test it to ensure it works properly and accurately. The project did not require many materials. All I needed was an up-to-date computer that could run the software, and secondly, CT scans showing positive cases of lymphoma and negative cases of lymphoma. Because lymphoma can spread anywhere in the body, we decided to specifically specify it to pulmonary lymphoma, which is lymphoma in the lungs. And we were able to get data from 150 different people with pulmonary lymphoma. To respect patient confidentiality, I obtained de-identified scans from the Cancer Imaging Archive. I then went in and analyzed a portion of these images and scanned the tumor within them using information I gathered from our lymphoma specialist and online sources. Now, with all this complete, I can move on to part B of creating the actual program. I created a two-part program, with the first part being a visual detection software that would take in all these CT scans and put it into a format which the computer could understand. And then the second part, a machine learning software that would take all this newly acquired data and it would learn from it and be able to apply it into future scenarios. These two parts work in complement. Now, they can identify different attributes using the machine learning and visual detection software and apply this information to future scans. For our program, I used a base machine learning structure known as TensorFlow. Although this is commercially available, I had to adapt it specifically to our program. For our software, I first had to create a model, which basically acts like a cheat sheet. using information that the computer had gathered over hundreds of different scans with known results. Now, when the computer sees a scan it's never seen before, it goes back to the cheat sheet and tries to find the common attributes between the two. The benefit of machine learning is all of this happens in just fractions of a second. And even if it's never seen any similar type of scan, it can still use its cheat sheet to get a vague idea of where this cancer might be. And lastly, it gets better over time. So the more different scans that you give to it, the more it learns and the better accuracy it gains over time. Now for the last part, C, testing the program. The following 10 scans represented in the data table are an overall reflection of the accuracy and effectiveness of our program. For improved reliability, the program also gives us a confidence rating of how sure it is of its detection. This is crucial because it gives the radiologist assurance of the program's capabilities. As you can see here, the program had an overall accuracy of 87% and an average confidence rating of 49%. When I started the project, I created a success criteria of an 80% accuracy. As I found in my research, this is a sufficient barrier for proving the capabilities of the program, and further accuracy can be gained over time and with more data. Considering that over 600,000 people are diagnosed with lymphoma every year, I see the potential in our program to save lives. With the base model now created, I want to move on to other types of scans, such as MRI scans and PET scans, to get a more holistic view. I would also like to use this program for the accurate detection of other types of cancers, such as colon cancer and breast cancer. Thank you for listening to my project.